Building your own Zigbee components, such as your own light switches, lamps, or even temperature sensors, has been possible for some time now thanks to the new ESP32s. In the past, when Wi-Fi lamps were the ultimate solution, it was almost unimaginable to be able to assemble such devices yourself. That's why I'm even more hyped about it and want to discuss in this video whether it's worth it, what the hurdles or disadvantages are, and whether or how you can get started with it. Everything else after the intro. Enjoy. After ESPs first came out with Wi-Fi on board, which in my eyes really sparked a revolution because it finally made it possible for all the DIY enthusiasts and tinkerers among you to build your own components. The ESP32 then offered both a performance upgrade and the ability to directly connect Bluetooth devices. Because everything is on one board, it makes it extremely easy to tinker with and build your own components. However, I always had a little dream in the back of my mind to someday build my own Zigbee components. How cool would it be if you could take a regular light switch and you connect the two wires directly to an ESP, and with a bit of software, build your own Zigbee switch. This way you would be completely independent from manufacturers and could build and design your own components exactly as you want. Especially in combination with 3D printing, creativity knows no bounds, and you have virtually unlimited possibilities to assemble your own components. Thanks to the new ESP32-C6, or rather, it's not that new anymore, but with the ESP32-C6, this is possible because it now includes Zigbee, alongside Wi-Fi and Bluetooth. The problem is usually that when such an ESP32 is first introduced, the software side is always a bit behind. And yes, it always takes quite a while until the first examples are available or the first developers have actually implemented it. However, it has now reached the point where it is even included in the examples in the Arduino IDE. So you can basically download a sample code, and that's what I want to show you. So in this video, we'll implement it together. The practical thing about this ESP32-C6 is that in addition to all these wireless standards, it also has a built-in LED. Specifically, a kind of WS2E82 LED. Let me see it. Like the LED strips you've probably seen in many videos. One of these LEDs is basically soldered directly onto it, so we don't need anything other than this ESP32-C6 to test it out. Of course, there are plenty of so-called GPIO ports on the side of this ESP, which are connections where you could theoretically also connect an external LED strip. So if after watching this video you're really eager to build something like this yourself, you can simply order a larger LED and connect it directly to this ESP to control an external lamp. The same would naturally apply to a switch. You can also connect it directly via a GPIO pin and then control it remotely. Alright, enough of the preliminaries. I would say let's grab a computer and take a look at the software side together. Just briefly, before we continue with the video, I want to thank all my viewers. As I do in almost every video, there's an Amazon code here again. For the first person who sees it displayed, feel free to redeem it. If you don't belong to that group and are watching the video later, feel free to click on subscribe. Help me improve this statistic a bit and maybe be the lucky one next time to snag such a voucher. Thank you to everyone, and now let's continue with the video. So, and here you can already see my screen. I am here on the Arduino website because first of all, we need the Arduino IDE, which you can download here depending on which operating system you have. Once you've done that, we can also go directly into the IDE. I already have my sketch open here, but don't worry, I'll show you how to get there. But first, we need to install the components for the ESP32-C6. For this, go into the settings of the Arduino IDE and then paste this URL in the additional boards manager URLs, which is also linked in the video description. Afterwards, you can click here and then we see the boards manager. Here we enter ESP32 and then find the ESP32 by Espressif. And there, we can click on Install. It's best to select the latest version here. And then we've almost done it. All we need to do now is click on this icon up here. Then select other boards and port, enter ESP32-C6 under boards, and then we find the ESP32-C6 def module. We select that here, and then we've done it. Now, of course, we need to see how we can access the code for it. So we can create our own Zigbee device. And conveniently, the Arduino IDE has already prepared quite a bit for us. If we click on File and then on Examples, we get a list of examples that we can use directly. And if we scroll all the way down, we find Zigbee here. And then we already see a lot of examples here. In my case, I want to control the internal RGB LED, so I directly will select the example, color, dimmable, light, click on it, and then the example opens in a new tab, which we can use here. We could change all sorts of things here, but we won't. The only thing we really need to change is the LED here. By default, it's the built-in one here. If you connect an external LED, you need to check where you have connected it and then specify this port here, and then you're done. Oh, and before we press the upload button, one thing I forgot is that we need to set a couple of things under tools up here. I have set erase all flash before sketch upload here and activated it. This means that the entire microcontroller will be erased before the new sketch is uploaded, just for safety. Next, I set partition HMASI scheme to Zigbee, ZC, ZR, 4MB, and so on. You can find it relatively far down in the list here. And finally, I set Zigbee mode to Zigbee ED, which means end device. A brief explanation of why I did this. In a Zigbee network, there are basically two different types of devices. One is the end devices and the other is the so-called routers. Both can be either sensors or switches. So it can be both a lamp and a switch, both a router and an end device. However, unlike the end device, the router can connect additional devices, thus expanding your Zigbee network. So if you have an extremely large apartment where a single Zigbee stick would normally not be sufficient, you can expand your Zigbee network with these so-called routers and effectively increase the range of your Zigbee network. The downside of this is, of course, that a router must always be online to forward the signals from all the end devices. This also means, naturally, that the energy consumption of a router is always higher than that of an end device. If you have everything connected to the power supply, it makes no difference at all, and you can easily have many routers in your network. That would not be a problem at all. However, there are also devices that are battery operated, such as light switches, and for example, motion detectors. And sometimes it's not so easy to find a power source for them. So, for example, you might not want to install an outlet somewhere on the wall just to power your motion detector, but rather opt for a battery-operated device. And in that case, it makes sense to choose a so-called end device, as it is significantly more energy efficient. However, it does not increase the range of your Zigbee network. I hope that was clear and helps you with your selection. Here, in my case, I am selecting end device here. This means we could theoretically use it as a battery-operated device here as well. This is also defined here in the settings, and you would receive an error message if you selected the wrong option. But you can also see here that this example specifically suggests selecting an end device. Once you have made all these settings, we can now finally upload everything. And afterwards, we can jump into the Zigbee to MQTT interface and integrate it into my smart home network. The cool thing is, it now behaves just like any other Zigbee device. So we just need to click on pair here after connecting it to the power, and if everything worked, a message should appear below indicating that a new device has been found. If we scroll down here, we can already see it. It is now labeled as end device Zigbee ZB color light bulb from Espressif. Then we can already see that it is, well, an unsupported device. But that's not a problem. We can basically ignore that and then click on details here. And then we can already see the options here, so the LED lamp, which we can now turn on. And ideally, it will light up right here. Now we can change the brightness here. I'll turn it all the way up now, and then we can also of course, select and control the colors here. And with that, we've basically completed our first device. The question that everyone should naturally ask now is, does this make sense? Should I buy a lot of these now and throw out all my other Zigbee devices? In terms of price performance, these parts are really very, very attractive and also extremely interesting in terms of size. If you take a look at the size comparison here, then yes, you can see that they can really fit into extremely small housings. Nevertheless, it must be said that the Zigbee market is already extremely good and above all, also affordable. So if you look around on the most common platforms, you will find plenty of Zigbee lamps and Zigbee switches. Accordingly, I would say that the effort to create your own Zigbee components is not necessarily worth it right away. Therefore, if you have very normal, typical requirements for a lamp or a switch, I would suggest first looking around on the common platforms to see if there isn't already a finished device available for that. Because even if you would save 1 or 2 euros by building something like that yourself, it is still relatively labor intensive. For hobbyists, the whole thing is certainly super exciting and also pretty cool, because theoretically you can also build your own Zigbee stick with it. So you can basically connect 2 devices directly with each other via Zigbee, which is quite fun as well. So for anyone who feels like experimenting a bit with it, it's definitely a great thing and a strong recommendation. And where I also see an incredible advantage is when you assemble your own components. So for all DIY enthusiasts, it's definitely a really cool project because you could control your own DIY projects directly via Zigbee, which in my opinion makes the whole thing more reliable and, of course, theoretically, battery capable. I'll definitely leave all the links in the description for you, including a direct link to the ESP32-C6 if you want to check it out. I hope you enjoyed the video and above all found it helpful. If so, I would really appreciate a rating, and then I would say we see you in the next video. Until then, take care, have a good one, and goodbye.